Okay. Um, so from my side,
Uh-huh.
I got this it, this model. It just feels very weird. Um, th- was there any further follow on that you had from our last
No,
discussion?
no.
Positive,
Yeah,
negative, what?
positive. Well, did my usual download it and listen to what we were talking about. It still seemed to make
Still sounds good,
all
right?
sorts of yeah.
Yeah. So, but what's weird about it is it it drops a huge amount of code, and it's sort of also it's very hard to stop thinking in a way that has the the web bundler and the API and the runtime and like all this crap, and it's actually sort of hard. It's been quite hard to come up with an architecture that doesn't consider that. Um, a simple example is like logging. So I would typically do logging in the client side. Fine, I'd do logging on the server side. I'd fuck around with it a bit, and then problems come up, problems go away, whatever. But I use the logs to trace it down. But in this model, there isn't any. Like it's just you just write to console, and that's it. You're in the browser. You're also in the server at the same time, and so everything's very direct.
Mm-hmm.
Um,
Mm-hmm.
so I've come up with a model for giving us a very very quick and dirty working prototype. I don't have it on me at the moment. It I thought I would have it by tonight, but probably next call on Wednesday I should have it. It's I can't think of what else to strip out of it, so probably there's lots, but whatever. Let me see. Is that you can see that? Or is it too big?
And
It's
it's
quite big, right?
well big enough.
Well
It's
big
yeah,
enough. Okay. Well, let's fix that because I don't.
yeah, yeah. That's good. That's good.
Okay. Right. Now. So because it's been quite hard to reason about, I went through and I tried to actually design it for once, for better or for worse.
So you never have to do that again.
Nah. Uh, so I came upon a number of principles. Uh, let me just refresh myself as to what those were. So some new names. I'm called. So we have an agent, where an agent is not necessarily powered by AI. It's just simply an isolated piece of compute that is controlled somewhere else. And you and I have debated at length what the meaning of agent is.
Mm-hmm.
It was like philosophy of artificial intelligence. Sorry. So
You had to be a
the
bit more specific.
yeah.
Okay.
Blah 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 blah. An agent is defined as I don't bloody well know because it's probably not here. Whatever. But the point is that an agent is something with is usually long lived, something with goals, something with a task. If I think of agents in everyday computing, you have like the SSH agent, which is there to help you. It helps broker connections to SSH servers in a way that means that you don't have to hand out your key each time. So the
Mm.
agent sits in the background when you're in a session and you want to connect to somewhere. You're like, "Hey, agent, sign this," and it grabs the thing, signs it, passes it back, and in that way you never leaked your key. You just did some signing.
Oh, that's interesting. That's different from.
AI
uh,
agents kind of came in and just like rode roughshod over the definition of agent, but a computing agent has been around for decades. And the
yeah.
reason why I want to bring this up now is that the architecture, what I've tried to do is instead of having an external thing, I've tried to remodel Artifact around this new paradigm. So, um, in essence, these containers are they're like computer agents where they work on behalf of Artifact, which is the coordinating process, and then each one of them has a very standard interface, and sometimes that interface is adaptable and that you can tell it to load other programs and you can tell it to do arbitrary computing. Some of the things you can tell it to do involve an inference engine, so some kind of an AI behavior in there. But the agent, the agenticness of it is not the fact that it has AI, it's the fact that it is an independent process.
Um, yes, to a certain extent. So way back when I was in uni, an agent was something that had agency. By agency, it didn't have to be intelligent. Agency could be a thermometer that changes its value without any input and just does it.
Yeah, that's pretty much it. Um, and so the way that I've remodeled this is to think of it like before we were doing um, computation in isolation, where the computation was not knowable ahead of time. So it would pull in arbitrary libraries from around the internet. It might have been code that you just made up on the spot, and it would run it. But it was always within the V8 isolate, the V8 the Chrome engine's blast radius,
Mm-hmm.
and therefore it came with those same restrictions, which is like very limited. It's a synthetic environment. It's basically the browser APIs. You've got limited file system, limited this, limited that. All your code has to be JavaScript or
It's a mini
WASM.
computer. Yeah, yeah,
Yeah, it's like a cell phone sort of. But
yeah.
when to abstract that away more, and to the reason why I like that model is because those compute units were very, very tiny, and it meant that you could do operations at a very high rate with a very low overhead. But the way I think about agents now is that if you fire up this container, first of all, you've got like a full file system, so you've got quite a lot of capacity in what you can do, and there appears to be some sort of ratio between the size of the agent environment and its utility, and the curve goes approximately like that. Like if you've got, it's like a mini sort of almost like a step function, where if you've got nothing or very little stuff, then like the Bitcoin blockchain has like, a handful of operations, so you can only do so much. And then Ethereum's got a few more, you can do a bit more. And then like JavaScript running in isolation mode has got this much more. Now the size is bigger, but you get more functions. But when you get to like the smallest possible Linux container, you get like 100 megabytes in size, which is pretty large compared to an isolate or a smart contract. But you get maybe 1,000 times more power. Like you get universal power. Anything you want, you can do. Now, you can make those images bigger and bigger, and the returns are diminishing. But basically, a 100 megabyte Linux image will give you, to pick a number, about 1,000 times more than say a JavaScript unit would give you, even though it's maybe only 50 times, 100 times bigger.
Okay.
So it's all I'm saying is that the power return is good up to a point, and then Yeah, I think you get the picture there. But the the way that I started looking at it was actually um, Artifact should do none of that computation because first of all, the blast radius, the server is the blast radius, so that's not great. But um, the agent, you can have one agent that's configured to run many different JavaScript isolates. That's no problem. It's just taking care of them. Like the agency part of it is that it's a sacrificial container. It's like you may die. Please run this code. And it like carries the bomb off to the distance, a safe distance from the server, runs the code, and then comes back with the answer. And it's like, I didn't die. And it's like, good, I'll write that down. Here's the next job. And it's that sort of a thing. And so you could think of agents as actually the compute units of the blockchain as opposed to these other definitions that we have floating around where it needs some AI in there. It doesn't. What it needs is remote control. It needs independent, isolated computing that's controlled remotely.
Right. So you send off a job, and it may or may not come back. You can run that in parallel with a few of them if you're a bit concerned.
Well, the lockstep thing still occurs because there's no difference between running a repeatable computation within the sensitive server versus running a repeatable computation on a container in the distance and getting the result back. There really is no difference.
Yeah, that's true, except for completion. Like if you look at a SAN,
Yeah.
what it really is interested in is completion. Did it in an uncertain world? Did anyone come back with an answer?
Right, but that's what a timeout is, because if your server died, you also are in arguably a worse position. Still no signal, but also no signal.
Yeah, but
Right.
being able to discern the difference of that. The logic is in the dispatch and retrieval of the result and deciding whether you got an answer.
Well, they would need like heartbeat and all that, and there's always a like a I want to say hypervisor plane, although it's a bit bigger than that. It's like the control fabric, the control plane of your
Yeah, that's
hosting
what we're
environment.
talking. Yeah, that's what
You
we're
know,
talking about.
yeah, and so you can always like, even if you send this job off, you can, and you don't get a response, and you're like, hey, control plane, what happened there? And it's like, like it just blew up, and it's or it's maxed out at CPU, and then it's like, all right, fail. That's a
Well,
response.
yeah. Well, you don't even need to know that. What you're interested in is the result. So you could fire it off 100 times and just wait for one response. And as soon as you got that locked in, happy days. You don't care about the other 99.
No, you do though, because like timeout or max CPU is a response. Like you need to record that. It's like this code is bogus. Did anyone else find the same? And then you reach consensus on that.
So if you have 100 clones doing a piece of work
Yep.
and one comes back and 99 don't, is there
Oh
any conclusion?
no, sorry. Yeah, I think we're talking about different modes of operation. I'm talking about the repeatability aspect, where you have several nodes, several computers in consensus. Each one of
Oh,
them has their own set of. So this is what I need help with a name for. Is like,
yeah.
what does that thing become? The thing that contains the artifact, which is the job management system, and all these Docker containers that are running various jobs. That thing is a computer by my books.
Yeah, it
What
is.
should it be called though?
Um, I hate naming.
I hate names.
Um,
If you're happy with computer, because what
it
else
is
would we call computer in our system? What is a computer anymore?
Is
We
it
just got browsers.
what's one above that?
A network of computers.
Yeah.
So if you have so you could have a quorum of computers where if they were running in consensus, you could say that this group of computers was in quorum.
I like that. So you have a quorum and you have compute blocks or computers.
I think
Computers
it.
is probably over-indexed in
No,
terms of.
it's well, computers has become free in terms of our namespace because like we're hitting everything with a browser. So what is a computer? It can't be a Docker container because that's too small.
Yeah.
And we've got a name for them. We call them agents. So I've been using one agent is one container. That's it.
Mm-hmm.
So
I
there's
suppose you
still
could call it computer. Yeah.
it is, but and it's the point is it presents like one trust boundary. It's like one secure zone where it's also expecting tight timing, like synchrony. Whereas a network allows for great deviations and packet loss. This thing does not. Inside this environment, packet loss is not tolerated. Latency not tolerated. This should be all sitting on. If it's not on the same hardware, it ought to be within the same rack or within the same data center at least. Like that.
Mm-hmm.
It's a computer.
Mm-hmm. It's okay. So let's go with the computer.
Okay. All right.
Quorum doesn't mm, uh, doesn't chime. I know what you're talking about.
Yeah. Well, look,
But
let's park that because it doesn't matter if it doesn't chime because we got three major steps before we're even worrying about quorum.
all right. Okay.
So
Go.
this first design I have misplaced artifact. There is just I'm like, well, we need the blockchain piece for operating offline and operating under contentious environments, but we don't need it to prove out the computing model. And I'll explain how I got around it.
Right. Okay.
Um,
I've got a side question.
okay.
But you go ahead. Go ahead. I'll come
So,
back.
yeah. So we've got this notion of this control plane.
Mm-hmm.
It's able to create new agents, where in our model, an agent is a single computer. A single Docker container that has like a control header on it, where the control header is like turn on, turn off, do this job. What's the response? Like this is the authentication thing. Here's a
Mm-hmm.
signed message. Those types of things. That's what we're calling agent. And then when you look at it, I've made this concept, which you can sort of see up here, called a face. So an agent has one or more faces, and a face means you when you come in on wait a second, I had it, and this one. When you come in on a terminal session like this,
Yeah.
you this is just one face of an agent. It doesn't seem right to make it that you can only have one view of an agent because an agent is trivially capable of having multiple views. What seems to matter is that inside the agent there is the mutability, the working directory within the agent is that's the thing that kind of like it's shared. That's shared across all faces,
Mm-hmm.
and so
No, sorry. Rewind 10 seconds. Shared across all faces.
of the agent.
So an agent has multiple faces.
Yeah, because an agent should be defined by its it represents a transient state before committal to the data set, be it a
Mm-hmm.
git commit, a block commit, any kind of commit. Inside of the agent is the transient computation that's sometimes hard to pin down. It's definitely the thing that the observers of the system want to see. That's what you want to see inside is how's the computation going, and then you want to say something else about it immediately.
Yeah.
And so that way of looking at it, I've described as a face because it doesn't make sense to only have this one way of looking at that type of thing. Because
Have
I
I
might,
got this? Yeah, have I got this right? So, what you're saying, I think, is you can get an agent to carry out a long running task, and say it takes 30 minutes. 10
yeah,
minutes in, you go in and say, "Hey, how are you getting on?"
yeah,
That's really important.
that's the critical thing. So in the
That's really
old
important.
way, how the hell we were going to see inside of a blockchain transaction that was operating was a massive pain, right? And it was all sorts of gymnastics that I had planned to try and give us that. But it turns out that that ability is the key to this whole system. Like this whole system is nothing but that. It's liberal authenticated views inside of the processing units that are working to make the next whatever it is.
Right. So if I interrupt it
Yep.
and say, "How are you getting on?" It should be able to give me an answer saying,
Yeah.
"Hey, boss, I'm halfway through this.
Yeah.
Here's what I'm thinking so far."
Correct.
And I should also, therefore, be able to say, "You're going off stream here. How about you think about this as well?"
Right. So what I
And
should
that'll
be
be
able to,
injected.
yeah, correct. But I should also be able to do something like this. So I got Codex running on the left-hand side here. I should be
Yeah.
able to come into that same agent and fire up Codex in a separate terminal like that, and now run something different. Maybe I'm in a different part of the file system. Maybe I'm, maybe whatever. The point is that it's the mutability state, the working directory of the agent is the thing that makes it unique, not the faces, not the way that you're looking at it, not the view you
Yes.
have in it, right?
Yeah, because that's exactly how you talk to a person.
Yeah.
It's like, hey, marketing person, how are you getting on with this 2 week task?
Well,
And
for
they,
okay, to use that metaphor, you might email them, someone else might WhatsApp them, someone else might talk to them in person, someone else will give them a phone call, there might be a smoke signal. The point is that there's many different faces that individual presents depending on how you want to interact with them and communicate with them, but they're still one mental space.
is
Thus,
there a way to stop it doing an ADHD thing where, yeah, I can report on what I'm doing, but I can't stop what I'm doing until I stop?
there is, but that's programmable and configurable. As well, you could also program an agent to only have one face, which means it's just going to only give you a view,
Right. And
right?
that would depend on the task.
Yeah,
Yeah.
but the reason why I bring that up is that without that concept baked in there, like you can have a multi-face system and only allow one face for this particular job, but you can't have like one face, one agent, and then suddenly have multiple ones. Like that doesn't work.
Yes.
So that's why I put that in there. Um,
Yeah.
okay, so
I like this concept of face.
yeah, all right. So what that means then is that the way the system works is that the browser is named the face viewer because the browser, like you see in this very tacky version, the concept is that the browser can only see one face at a time.
Yes. Okay.
Okay. Now, how you make that work is there's this one component that's part of every computer called the agent router. The agent router, first of all, when let's assume you passed all your auth and you blah, 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 and then you point your face viewer, which is the browser, at the agent router for the computer. And you say, I want to see agent ABC, face number 2. The agent router will look into the collection of of agents that are running. It'll locate the agent, check the auth, check the permissions, whatever, and then it will route, or it'll proxy the face of the agent through to the browser. And so that's exactly what you're seeing here.
What does WS mean?
WebSocket.
Right.
And so the browser at any one time is pointing at one face. The agent can do an operation called handoff, where the agent can, using the MCP calls here, cause the browser face viewer to relocate to pointing at a different agent and face.
Okay, why would you want to do that?
Well, I'll start with a simple example is if you want to get the status of all of the agents in the computer.
Yep.
Different agents are tasked with doing very narrow things, otherwise we know they lose their minds. So there's one agent that specializes in managing the other agents. And so you go and view that face, and it shows you the tree of all the agents, what their tasks are, their latest sort of reports that they sent in, like they estimate they're 90% done, or they've burned X number of kilotokens and all that stuff. And you see it in a tree, like the proc tree in Linux, right?
Yeah. Yep.
And then you see one and you're like, oh, I want to drill into that. And that's when the proc tree agent would call handoff, and your browser would repoint to now the one you wanted to drill into.
And presumably the browser would allow you to go back.
Yeah, and you click back, and now because now you're in a different URL. So the cleanest way I could think of to model this or describe it is to list all the different URLs that the system needs to handle.
Mm-hmm.
I think this is overly verbose, but so if I was looking at your app, other agent, face 0, and it did handoff, and it redirected me to face 1, then the back button just would go back to that URL, which is just face 0.
Right, okay, that's easy enough.
Right? And so you can navigate yourself as the viewer, like back, forwards, bookmark, home, all that. But the agent that you're connected to can also redirect you based on what it thinks you want.
Mm-hmm. Mm-hmm.
Now, the trivial case is when you're active and you're browsing and you do some stuff, but quite a nice way of describing that is to describe the boot process. So, when I'm trying to boot a new agent, what would happen is first I would come and I would view. Ew, crumbs. How do I? So first I'd come into the computer and I'd get the default agent. Even though I've got extra parameters in my URL that say that I want a specific agent and I want this face. So first of all, I'd come in and let's imagine that everything's been shut down, it's been snapshotted, and the thing's gone down to like super low resource mode where it's really just the state that was saved. And now I'm like rebooting, rehydrating, getting everything back again. What I would see is first I would get pointed at the face 0, which I've reserved to be a special face, which is the booting, basically the system face, and it's read only. First I would get face 0 of the default agent booting. So I'd see it'd be like my browser's flicked in, it's now showing the boot process of this container as it comes online, and then it gets to a certain stage, and now it's got enough resources that it's like, oh, hey, you actually want agent XYZ. And so it goes handoff to XYZ while at the same time boot XYZ. And now your browser points at the boot process of agent XYZ as it comes up. And then finally agent XYZ is online and it's like, oh, you wanted face number 3. And so then it like flicks you over to face 3 on agent XYZ. And so what you've got is your face viewer has been navigated through the various boot processes of these agents as they came online, so that it's a form of progress, but it's also logs, it's also status, and that's where you would repoint the viewer as the capabilities of the system came online to ultimately get to where you wanted to go, even though it wasn't available, it wasn't hot when you came. Like, you came in cold and it walked you through the steps to get you hot.
Is there? This is probably a stupid question. You've got parent agent and child agent, both of which have a face.
Yeah.
You're in the child agent, and you with face 0.
Yeah.
You're in
So the read-only boot face,
Yep.
and you're just watching it, like getting its stats and whatever.
Yeah, and
Yep.
you want to change the face of the parent one because the parent's got a few things to do.
Mm-hmm.
I want to see, hey, can you tell me a bit more about what the child is doing? Is that possible in this?
Well, I'd imagine you'd go back, like, because you want to know where the parent is, right?
You would go back, wouldn't you?
Yeah,
You'd go
because
back
you
and
wouldn't have
change
been
the
able to
face.
get to the child without having come there somehow. And so
Yeah.
if you got there and you're like, oh, this isn't what I wanted, you'd go back. And then you'd come down and stop one level higher at the parent.
Right,
think.
because the parent can have more than one child, and
Yeah.
if you're in face,
Yeah, probably the easiest way would be to go home, and then from home look at the process, the proc tree, the process management tree, and then trace it down and go parent or right click, what's it doing, something like that.
right. So if you want to go back, and then you could change the face that you're talking to with the parent.
Yeah.
And then have a different view.
There was also seemed a good reason to have the ability to fire up a new face if the agent supported it. Like, if you just go to no face where you didn't specify anything, it would give you a new version of its best face. So like face 0 was for stats and like things that are always there. And then if you blank that, so if you went
like a default sort of thing.
Well, yeah, if you went in there and you went, I'm on face 1 and your example was face 0. If I take that and then I delete it, I delete it. Fuck. Then I hit that URL, that will create for me the best face it can, which might still be read-only depending on how the agent has been configured. But the point is that if you land and you don't specify a face, you probably mean a new one, please. I don't know. Look, there's all sorts of there's sort of like nuances and conventions and defaults and things that we'll work that out from just the kinks in it. But it's really about the overall the names of the concepts.
I like the idea of face.
A face,
a lot.
yeah. Because that doesn't mean it has to be a browser, right? Like, it could be a VR representation, it could be a piece of hardware, it could be anything you like.
Right.
And so where this really starts to shine is in this piece, the face hardware connector. And so when the agent router is pointing you at an agent face, it's also pointing your hardware to that agent face, so that the browser's mic, camera, screen, clipboard, all that can be controlled with permissions, of course, when based on the activities of the agent, and in particular the activities of the agent face. And so if you wanna stream your video in, you can't do that on SSH, right?
Right.
But with this hardware connector, you can stream your real-time audio into the agent, and to the agent it looks like a sound card on the container.
Right.
Right? And so you got all
Agent container to hardware bridge is an NCP.
yeah, because it needs to go that away. It needs to come out of the agent and talk to your hardware.
Right. And face hardware connector is the one that actually deals with the.
So that's the bit that sits in. So visually, if you thought about it like the black screen here is the terminal, then the bit above it is the local the browser piece of code that hooks up the resources that the browser has, converts it into this form that's MCP controllable, and then waits and responds to see what the face asks it to do.
Right.
And that's how you bring the hardware in with you. But that could be anything. It doesn't have to be the browser's hardware. It's just saying that as you navigate around, you can connect in arbitrary things into these agents, no problem.
So into the agent container, which
Yeah.
ultimately will deal with whatever.
Yeah, and then you're coming in with pure binary, with very little latency. There was no translation step. There was no, like you got about as close to raw access as you could, and now you're sitting there on a container that has very good binary processing abilities, because it's not synthesized in any way. It's not a V8 instance. It's like an actual Linux box. It's very good at streams of bytes.
Right.
And so the agent could. So when you do something in the frame, like you're like, turn on my camera, you don't turn it on here. You turn it on in the terminal session, which goes through the agent router and into the agent container, and then the agent container receives the instruction to turn on the camera, and so that's when it makes the MCP call out to hit your hardware to tell the system to respond.
Yeah, that's neat. That's nice.
Yeah, and so in terms of like, I know that looks like a long round trip, but if you look at the latency, like this is so I'm in Auckland and this is heading Sydney. There's very little, there's very little latency in the terminal. Like it's not really perceptible, because first of all, the amount of data is so tiny. The access is so direct. There's no buffers in the way. There's no protocol changes. There's no decoding. There's no like muxing of the streams on the like it's not having to pack things into multiple streams. Like it's the wire. It's basically the wire.
Yeah. And what would happen if I asked two agents to access my microphone at the same time?
You couldn't. The model is that your browser is only ever pointed at exactly one agent at any given time. That's the model. This is the principle that I came upon. That's what I really want to impart upon you, and to make sure I haven't cut off too much. But that model seems to do everything, and you avoid a whole range of ills, some of which you just described.
Mm-hmm.
It's only talking to one agent. And when this agent goes handoff, it goes MCP tool call, hardware bridge, navigate. And that thing drives this page to go somewhere else.
Right.
This thing we could very easily make a plugin that goes in here that can actually do things like make a new tab, move the tab, activate the tab. Like it can be aware of arbitrarily many things. Like it can be aware of your browser state if we want. It's a way for the agent to sort of reach out down the tunnel, and I don't have any metaphors that aren't unpleasant, like a sock puppet or something, but that's sort of what it's reaching down the tunnel, and it's controlling the computer on your behalf. You make your hardware become an extension of this agent, even though the agent is far away, deeply hidden, sitting in a private network in some data center somewhere, right? And that was really the thing that was hard to get at in the old model. I was like, how do I even stream out the AI process that's coming out? I can't even stream it down so we can see it, let alone stream it in a group setting where multiple people want to see it. But here, that is the only model, is visibility of the running computing state. And it feels very weird.
No, I can see it working though.
That's the thing. It works, but it's actually lopped off huge chunks of crap. And I just I can't actually see anything wrong with it, and it just makes me a little bit giddy to have to rethink how I do things.
But you get isolation for free with this, I think.
Well, it starts isolated. You can't not be isolated. Like you can't turn the isolation off. Is the
Yeah.
And the scale comes with that. Like you can boot 2,000 agents. It ain't gonna. It's gonna cost you maybe, I don't know, $2.
Yeah. And then you got, it's nice.
Like massive trees of workers can just fire up for no real. I mean, the hardware owners might complain that like you guys saturated our VMs for 10 minutes. That's rude. But in general, you can have much more compute than you could ever access in one computer. The model stays the same. You just have more agents.
Jesus, and it's lightweight at the front end as well.
It's stunningly light, and that switch is like effortless. And when you switch, you also get status along the way. Like if the machine's still booting, you can see it booting. You're like, I'll come back. So you go back. It's not like I have to build a state machine to describe to you what the status of the machine is, where I chose my language, and then when you're like, I want to know more.
If it takes more than 4 minutes, whatever, you can come in with a different face and say, hey, what's up?
Yeah. Or you can be like, hard reset, that thing's dead, or the watchdog kicks in, or whatever you wanted. And it's just extremely, it runs very cold. Like there's very little compute other than the job. So the amount of energy that goes into doing your work, if that was a measure of efficiency of the system, it would be very bloody high.
And you could presumably boot up another agent to look at the faces and tell you if you've got a whole bunch of these kicking off, say, I'll take 30 minutes. You could boot up another agent saying, hey, tell me how you're getting on.
Yeah. And we'll summarize this.
It would boot up faces. It would be able to interrogate and say, yeah, this one's lagging a bit.
Yeah.
Don't worry about it.
Yeah.
Yeah.
So they can talk to each other using faces, where they come in and they're like, hey, what are you doing? What's happening?
That's really neat.
It's kind of neat.
The reason I'm quite enthusiastic about this is because one of the irritating things at the moment is, as you know, you kick off a big task and it might take 10 minutes, 15 minutes, whatever. And it's telling you what it's thinking, but can't actually dive into it.
With here,
And
you can just come in on a separate face, and you can hit the logs, or you can fire up another process to interrogate using the AI as to the status of what the previous one's doing.
right, right. And I'm only talking about one thread. You could have multiple threads.
Yeah, right.
And you could just say, "Give me a summary.
Right.
Give me an exact summary of where you're at with this." It's like,
Yeah.
"Hey, boss, it's going to take another 45 minutes. We're still thinking about this. We've solved that bit, but this bit is really hard."
Yep. So it seems like this fits all of our problems.
Face hardware connector. That sounds pretty bespoke.
You mean more bespoke than a custom-made blockchain? It's it's not. It's really not. It's because thankfully browsers of the way that you access this hardware is very, very standard. Like there's like standardized strings that are thankfully English. I mean, I'm glad someone won the war, but it's a standard set of strings that indicate the hardware that you want to connect to. And again, the ease of the system is that the most complicated bit is pass through. Once you get to the other side, you have all of the Linux ecosystem on hand. You can use whatever anyone made to deal with it. Like there's no more of this, they don't have a JavaScript module. Sucks, right? Go, Rust, Python, JS,
so
whatever you want.
That problem's been solved then.
What do you mean?
As in mic to face hardware connector is an.
Oh, that's easy. Yeah, this piece
problem.
is this piece is easy. This piece is easy.
Right.
Yeah,
Right.
because it's very, very standardized. That's what the browser working group does, is standardize that type of thing.
That's excellent. Okay.
So they've done a great job there.
Right. And then hardware bridge. What do you mean by hardware bridge?
I think I mean a hardware router, but it acts like a bridge because it simply connects this thing through to that.
All right. Okay. So it's just a pass-through pipe.
Yeah, a proxy even, but
Yeah.
it's sort of a proxy does a bit more. The bridge is just like raw, like it just acts like you're not there. It tries to act like it's not there and just connects both ends.
Right. So if I want to use my very shitty phone, my browser face viewer is the thing that is actually running on the phone.
Mm-hmm.
I'm just going to talk through this to make sure I understand it.
Yep, sure.
So that's all that's running on there. It goes through the router and finds the container. The container is the heavy lifting.
The computer. The agent. Yep. The agent thing. Yep.
So if I say, hey, access my camera, that goes through face view, agent router, agent container knows about my camera.
Yep.
It goes requests
turn on camera.
Turn on camera.
Turn on camera goes here to the router.
Yep.
The router
and then
sends it through
with the interface to my camera.
Yep.
My camera goes, oh, right, okay,
bling
on it, and then starts to stream through.
Bytes
to
come
the
down.
Container.
Yep.
And then the container talks back through to my browser face viewer, presumably.
Yep. Well, the agent does whatever it likes with the stream of bytes, and then depending on how it can choose to update the view any way it pleases.
Yeah. I don't see a back path to my browser face viewer.
What do you mean a back path?
From agent.
What do you want the back path to do?
Container does stuff.
Well, the view here is just the SSH session. So when the agent does stuff, you see it. You see it in the terminal.
Oh, right. It's just because it's one-way arrows.
Fair enough. You know, tragic story. I couldn't actually get, if I made that a one-way arrow, I couldn't get this bit to be on the left. It would automatically, due to Mermaid Diagrams auto layout.
Yeah,
So
mermaid
if
shit.
you could please just not scrutinize the direction of the arrows too badly. But
Fair enough.
this one here is like it initiates the question, because the browser gets told where to go, and then it goes, hey, agent router, I'm trying to get to here. Agent router does the telephone switchboard bit, points you at the agent, and then that's how the connection gets made.
Yeah, the most exciting part is all the heavy lifting is offloaded, and so Dark Edge wise, this is surely compatible, right? So I have a small device.
Yeah. Like your device can be like stupid as fluff. Like it can be.
As long as it can run a browser.
Yeah, but also like the bandwidth is like you can't get any less bandwidth than just the characters required to send the text back and forth.
Yeah.
There's no downloading of like this freaking 2 megabyte web bundle or this thing and that thing, right? You can still do images and all that, and you can still decorate these things with fancy buttons and what have you, but you don't need huge amounts of logic in the browser anymore. And trivial case, you can just take the text stream as it comes. It's like you literally can't communicate digitally any more efficiently than that. You're not.
Yeah.
And it's compressed too. So I don't know, what more do you want? Like.
Yeah, exactly. This is really cool. So I could. That's something like I don't know. What am I seeing on my screen?
Yeah,
that would go all the way
well,
through.
the agent knows.
Find it.
Yeah, the agent knows what it's showing you in this model too, without any difficulty.
Yeah.
Whereas the other way with the whole browser thing, it was like kind of awkward. You had to make your app the right way, and it was, to be honest, never going to go anywhere, even though we tried.
I like this.
What was the last thing you liked before this?
Sorry?
When did you last like something?
Oh, I quite liked our last conversation.
Okay, sorry. No, I meant like not. Yeah, I don't know. It just
The reason I like this is because it's very lightweight on the device. You're offloading to the agents. The agents can do its own thing, and can do the heavy lifting, and still bring back information from your device.
Yep.
That's pretty neat. That means devices can be very low power, very
yeah,
shitty.
Yeah. So I don't know what the correct name of the metric is, but there is a metric about energy expended towards your purpose, and this system I think would score excellently in terms of how much energy it takes to do what you wanted versus the overhead or the admin.
Joules.
Yeah.
Nice.
Okay. So the other.
One other question. How straightforward is this to code?
Very straightforward to code. What's been hard has been to, first of all, get here. Second of all, to design how the multi-tenant version should work with authentication and all that. I think I've got a pretty good design that I'd like to go through with you.
Mm-hmm.
So this I will use my trusty whiteboard for, because
back to the crayons.
Crayons. Yeah.
Ooh.
It's a bit of a blast from the past, isn't it?
Mm.
Reset the canvas. I am sure. Now, so what I got going on here, because I have been trying to balance everything to not be bending to the architecture of Fly.io.
Yeah.
So what I got going on now, if we'll just treat Artifact as if not there, because if we just imagine it, it's a database that just holds the latest state, and that's it. We'll deal with, okay, you got a user's browser, and then it comes in, it hits the root domain. So let's call that dreamcatcher.ai. It comes in when it is authenticated. What'll happen is it'll redirect you to your own URL. So your URL is going to be like maxwell.dreamcatcher.ai. That's your computer, and that in Fly terms is an app is a collection of any number of machines, where the machines are, in our language, agents, and the app shares secrets between it, but it's isolated. And so what the design I'm going to give is when you sign up and I make you your own app, you are now able to make your own machines within that. And so our billing is just for how many machines did you make, how much did you use, and all that. But it's really any one of your agents can make a new agent as a child.
Right. So my landing app, Maxwell Dot, is me. That's my primary interface.
Yeah.
And then inside of that, there are any number of further apps I can create.
Not apps, agents.
Okay.
So an app in Fly terms is this. Well, I'll show you. Again, I don't think that this design hinges too much on Fly's definition.
Yeah.
But so each one of these, for example, is an app, and inside the app, that's where you get things like how many machines, what are my IPs.
Oh, right. So that equates nicely to my account.
Yeah, it equates nicely to your account, and so your machines are within your account. So your list of machines is here, and then here's these two machines that are part of your account. They're in Sydney. This is the size of them. This is the the off. All these things. So we could pretty much even just give you a login here, and then this is your app.
Yeah. Okay.
And in our language, that's a computer now.
Yeah. So I now step out of that. Say if we've got two things that I want to do.
Yeah.
With different agent trees. Then I go from the app into one agent tree and do a piece of work.
Yep.
CRM.
Yeah.
Different piece of work.
Yeah.
Accounts.
Yeah. But the constraints of the design is that there's always this concept of a self agent, and you can have multiple ones, like for resilience. So I can have like here I've got two, because these are each on a different physical host, and so if their physical host has a problem, one of them's always reachable. And so these ones are the ones that receive the inbound traffic from the outside at all points. The only way you get into your app is to go through these. These are like the gatekeepers.
Sure, but
the
both
gatekeeping agents.
gatekeepers have got access to the same state, and so you don't really care as long as one's up.
Yeah, that's right. That's right. They can do the same stuff. And
Yeah.
what happens is you come in there, and first of all, they'll check you for authentication. Are you allowed to be here? Da 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 da. And then they are what you talk to then jump off to other agents or find out more about the system, deploy more agents, kill some agents, all those different things. And so how that works really neatly for our base domain, like Dreamcatcher.ai, is that you'll come in as a member of the public, and our gatekeepers will be set public, so anyone can talk to them. So you'll come in, you'll be presented with a new face on one of our gatekeeper agents, of which we can scale up and down for load. You start chatting, it's like, what's all this about? It tries to convince you to create an account. When it does, that's when it trips off the process of making you your own computer with your own gateway agents in it. And it's at each time your face viewer is first of all pointing at the gateway, then you go and you point at the provisioning agent, the one that's making the new app for you, so you see the progress. And then once your app comes up with its gateway machine and it starts booting and is able to accept a viewer connection, you get pointed at that, and now you're on face 0 of your gateway agent, or one of them. And then once it boots up enough, you're now in face 1, gateway agent. Welcome to the Dreamcatcher.
Gotcha. Is the that face 1 gateway agent a child of the Dreamcatcher agent?
No, because it was made in its own app. The only thing different between the base Dreamcatcher computer and all of the user computers is that the Dreamcatcher one can make other computers.
And then spins them off, and
now they're on their own. Yeah,
gotcha.
But actually even that's not really a true restriction, because even now that you've got Maxwell.Dreamcatcher, you can make another app that will be billed to you, but it could be an org.
Yeah, that's true, actually.
But
yeah.
That's the flatness. There's no, the nesting between computers is only logical. From the point of view of the hardware, it's flat. It's just apps. And so the model that I want to collapse or do away with was, in the past, I used to think that our repos, each repo could, if it wanted to, have this, it's got a consensus branch and it can do computation and all that. But really, you only need that if you're a computer. You only need that tracking of what is the processor tree and how do these things talk to each other and how do you recover them. You only need that for one repo per computer. And I think it's even one branch. So I think it's one branch per computer does the computation management, because I don't know what the point in forking the computation is, because you can't, like, you can't, it doesn't really work like that. And then the rest is just plain Git repos, because what if all the computation is happening somewhere else? Like, that's the rule that I think it is that the computing is happening in one branch on the one repo that represents your computer, and it's all that repo does is just manage the compute state.
Which makes sense, which is very movable. And yeah.
And so Artifact becomes a lot simpler there, and also I can make all that for now so that we can just play with it and see how it feels without Artifact anywhere, because the machines have a free-form field called metadata that I can store anything I want in. So I can store, like, the agent name, who its parent is, what its children are, just within the metadata on the machine, just using Fly.
Mm-hmm.
For getting us up and running, I think that's vastly the quickest thing to do.
Mm-hmm.
And then we'll just play with the with the model, like see how it works. So you can, I don't think you can see the metadata here. Yeah, here it is, metadata. Like I can add extra name value pairs to the machine metadata. So the shortcoming of that for us and why we need Artifact long term, if this model works out, I really hope it does, is that if the machine dies, the metadata dies, and so the proc tree has a hole in it or a fault. And also, if you need to, for economy's sake, stop machines or destroy them so that you don't get billed for the idle state of them, then you need Artifact to sort of hold that snapshot so that you can rehydrate it later.
Right. Yeah.
And then obviously if you want to go dark edge, you need the blockchain bit, but we can defer needing Artifact for the sake of speed because I want to understand how this computing model feels, and this face viewer thing is like very, very exciting, but it's just weird, and I'm not sure. I feel like we got a good handle on it, but there's nothing like being there.
Yeah, I quite like face, because it's like giving someone a long-standing job and then interrupting them with an email saying, "Hey, how are you getting on?"
Right, and they got to stop the job to answer the email when they could have just finished. Yeah. But I also think that we got to be careful, I'm not sure how, to make sure we're thinking beyond just the turn-based AIs that we have right now and these like single channel communications of your turn, my turn, your turn, my turn. I don't think that's the long-term way things are going to be, but it's how they are now. I just think that this computing model, because we've sort of rolled it right back and said that actually when is a machine intelligent and when it isn't it? And it's like, well, if it can boot, it's a form of intelligence, and that's what makes it an agent. And so this model works for classical computing as well as AI computing, and I want to say therefore whatever form factors the AIs take on next, this model surely would still remain.
Yeah, I think it would.
It feels like a universally useful model to hold to.
You've touched on something I've been thinking about, which is this turn-based model is not going to be where it ends up.
No, let's not go into that now. That feels like a good long journey down down the theoretical. So what now?
Well, I don't know. You tell me. When's it?
Well, look, I was hoping I would have this thing, but I think we covered the app model, how that and the user model.
That's got to be one of your finest whiteboards. Yes.
It's about the information quality, right? Nothing but quality. This is not booting correctly, this page, but this is what I'm working on now. So this is the face viewer that can be switched around. Yeah. And so the component I'm putting in right now is the ability for it to make a new machine for you. And once you have that, then you've got this ability for agents to talk to other agents and create them and shut them down and control them. And that's when you can build loops and processes, things like that. As for Artifact, there's another piece has come to mind that is deferrable, but so there's an optimization for Git that I believe we need medium term that is not available anywhere I can find it yet, which is the fact that one of the things that Artifact did very well, which I'm sad to say I don't think it needs to do it anymore, is the ability to virtualize the working tree, which is to say that it can make the computer think that it's got the full checked out repo, but actually it doesn't. And it's just when you go to read something, it's only then reaching out to the repo objects and unpacking them and giving it back to you and all that. So you could have a repo that was massive, but it takes up no space except for what you read.
That sounds quite useful. Why is that
That's
being backed off?
that's how it works in the Deno version, but now we have these Linux file system versions. They can't make use of that, so they need to check out the Git repo fully. And that's a non-instant process, especially when, things get hot and heavy and they start happening fast. That process starts to choke us a bit.
That's a shame. Yeah.
Yeah, but what I have learned how to do is I can make a file system in user space that can mount within the container that can do that same trick, but just present a genuine file system rather than the hobbled one that I was presenting to the application, because it needed to run within the constraints of the V8 isolate. So I can present a file system layer in Linux that does that virtualization of the objects underneath. So it like makes it seem like it's got the whole thing, but it doesn't. And I honestly think that the bad news, mostly for me, is that I think that can replace the Git work that I did on Artifact, because that's a much more performant way of doing it, even for the blockchain component or the process management component, because it's still just a Git system. And so once you have this file system layer, it's going to be far more performant than the JavaScript one that I made. Plus, it's got all these extra features like optimizations for doing like history walks, and there's all kinds of like cutting edge types of features from Git that come out fairly regularly. Like, it's probably one of the most boring subjects in the world is the Git changelog, but slowly but surely they release some rather remarkable performance improvements, and we can take advantage of all of those if I make this file system layer. And that's probably, I think that's us done. Because you got this high performance virtualized Git. You're using that Git as a process management tool plus a state snapshotting thing. You then have these agents that are able to do calculations of arbitrary form for you, where some of that can be consensus, where you're talking to other computers to agree on a state. And then from there, it's about what you do with it on top, which is the end of my job.
Yeah.
So that's it, I think. That's the model. That's the end.
I can think of so many in the hopper.
Yeah, but then,
like Ossend.
I know, but then those become like prompting jobs plus like they're no longer infrastructure jobs. They're no longer back-end coding jobs.
It's Ossend is prompting and storage. That's it.
Prompting storage, yeah. And then like going dark edge is like, dark edge is just making these Docker containers, making Firecracker run using not fly, which is not trivial, but it's certainly not hard, particularly not if we've got a system like this up and running, and we could go a long way just on fly.
Yeah. We take our time on that one.
Yeah.
Fly doesn't look like it's going anywhere anytime soon.
No, they're actually really good, and they're very cheap. So
yeah. And even if you want on-prem, okay, so that's a job of work to do.
Yeah. So and on-prem's not. Yeah, it's a job of work. Thankfully, Fly has open sourced a lot of the things that they use to manage their hardware hosts. But I suspect that we can actually use Consensus to make the management of those hardware hosts even less of a burden than Fly. So I strongly believe that we can actually undercut them, because we can make adaptive systems that use the LLMs to do a lot of what's quite hard about managing a hosted service. And we can provide our own stuff that's more controllable more diagnosable, but it won't. It'll be all prompted, so it won't. You know,
Yeah, yeah, yeah.
I,
And
I think I think there's good money in that. I really do. Like it's actually you can compete quite strongly if you had that system where you're just consuming hardware at the hardware level, and then you're transforming it into reliable systems that you bill for, and your salary count, your head count's like nothing. So
yeah,
where's all the it's all margin apart from two
yeah,
salaries basically.
yeah, 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 yeah. Good.
Have I missed something? Like, are we?
I don't
Because
think
that
so.
feels
Well,
awful close. Like that's like the end of the job.
there's an awful lot of information there, so I might need to think about it. But no, I can't see anything.
I think that's the end of the job. So I don't know any other things that I have to do after that. Maybe go and live my life, perhaps. Um,
Yeah,
it
yeah.
seems like
There's
it
that
though.
bit.
It seems like all there is at that point. So
It does.
anyway, I'll get the version up working that doesn't have artifact in it and has an inefficient Git system where you'll have to just tolerate it doing a full blown checkout. I'll I'll rally through GitHub for now rather than our own in-house lightweight virtualized quick thing. I'll just
Mm.
push and pull up to GitHub, so it'll be what it is. But again, the token generation time dominates here, so
Mm.
hopefully you can get a great sense of, is it the right architecture? I mean, heaven help us if it isn't. I don't have any other tricks up my sleeve, but
Mhm.
is it the right architecture? What sorts of sugar do you need on it? Like what's good default behaviors? There's probably some annoyances that'll come up, and we'll smooth those out. Um,
Yeah, that'll
and
come from usage though. That's
yeah,
the
from
thing.
usage, and then it'll be prompting problems. Like, how do we control these agents for long runs?
But
Probably
it's
there'll
well
be some
defined.
cost overruns.
This might be cocky, but because it's well defined, I don't see the prompting being a problem here.
Yeah, prompting's hard though. I mean, you're probably going to be doing prompting for the rest of your life, I've got to say.
Well, yeah, I'm expecting that. I'm quite looking forward to it. But there's prompting in uncertain environments, which is much harder than prompting in well-defined environments.
True, true. But the key achievement that I want to see is the ability to have one agent produce a better version of another agent by improving its sysprompting.
Yeah,
And if we can figure that bit out, that would be one of the key aspects for me. And
I
then
think I think that is going to be a gnarly problem because of local minima.
yeah, we'll see. Um, and then ambient attribution, and then I think we're done. Hey,
I think. Well, I think we've got to the starting the starting line.
yeah, like we're different people then. Like we're different. We do different things then. Like we're not waiting for the system or trying to build the system or design the system. We're now users.
Yeah, yeah.
I honestly I got this feeling like we've forgotten something massive, but for the life of me I can't
Now
think what it is.
we're offloading a lot onto agents, but I don't feel anxiety around that
It doesn't
because
feel
the
wrong. It feels like the right place to put the cuts in the system.
yeah, yeah, precisely. And I mean, the sort of work, the useful work is around pattern matching mostly.
Yeah, right.
And
Like things like agile versus Kanban versus all these other things.
yeah, yeah. Or in fraud detection, in uh, even there's a trivial thing I'm doing at the moment around the accounts and that pharmacy thing I
Yeah,
told you
right.
about.
Yeah, right.
It's
But
I'm
again,
already
those are uses of the system as opposed to the system. right?
So when I'm listening to you talk here, I'm thinking I'm already making progress on these things. I'm thinking about, well, would the if I had this system, would it improve? It would save a hell of a lot of time,
Mm,
hell of a lot of time. And
mm.
then if you get agents improving agents, that I think is going to be the gnarly one.
Yep. So
Um,
agents making code seems to be going pretty well. Agents making designs, like this is my design system, and it's pretty good. I mean, yeah,
yeah, and I'm already using agents to produce sysbombs, effectively.
right,
Another
right.
agent. It's making it aware of the entire system should be fine.
I mean, it's all just text.
Yep, yep. Um, yeah. No, I can't think of anything.
Look at my
So,
references. Wahahaha. The runtime,
the interesting thing is, all these generated docs, nobody's going to read except AIs.
which has been pretty good because I was like, "Hey, read this doc. Make me the router. Make me the agent router." And it's like, "Sure thing, boss. Here you go." And then
I know.
5 minutes later, off it comes. And I don't know, man. It just feels like it's easy to make code now, but what is the right code?
Yeah. The reason I'm thinking that agents making agents going to be the problem is of you get it slightly wrong at the start, then you're going to get it very wrong at the end.
That's just life, though. I mean, what are
Yeah.
you gonna do?
Yeah. But then it comes round to a feedback cycle where you have an agent sitting on top going, "Well, where are you guys going?" No, 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 no,
Yeah,
no. Right.
yeah, yeah.
Let's
So,
try that again.
and then the next crank on the model handle. I mean, Grok 5 is probably the next one to watch. That'll be out soon enough. So I think if we can stand this platform up, and then we'll just ride the wave. Because I mean, not to be too nihilistic about it, but we don't have any more cards to play. Really, it's like this is the design. Um, this is the downloads
That's a
of the
lot of downloads. Bloody hell.
dude.
What's
So
that?
so that went from that went from 50,000.
In January.
Yeah, when Model Context came out here in November, I was like, "Hey, buddy, Model Context." That's when
Yeah,
it
yeah,
came out. Okay,
yeah.
50,000,
And up to six
right?
million, is it?
Yeah, and now we're like, "Oh, hey." So that was a version tick back in March when they
Yeah.
were at 500,000, and then there was a,
Whoa, what happened there?
I think Claude released um, built-in being able to connect MCP up to the desktop agent. I think I'm not sure. And then the latest version was this date, June, and now yeah, here we are, 6.2 million. So
Wow. That's
I mean, MCP is kicking off, but I gotta say, we had this MCP host concept. It seems a lot diminished now. We almost don't care. We almost start treating MCP servers like external things as opposed to internal things. Because what is there that I want to do internally that I wouldn't give to a Codex agent to run?
right. Right.
Now, there may be some constrained uses, like if we were modifying ledger balances, you'd probably want to do that via a tool call as opposed to via a freeform text edit. So there's things like that. But I think the utility of the general purpose MCP system has the floor's fallen out from under it. In my opinion, it's all about agents.
Yeah, but it's very useful that the rest of the world are standardizing their way of talking about
Yeah, so that's
MCP.
all the mutable systems in the world are starting to fall into line with this access pattern.
Yeah.
which is really just terraforming away from APIs and into MCP, and that's kind of where it's like that's how you talk to it now.
Yeah, which is really useful that the rest of the world
So
are
that's all good.
behaving nicely.
Yeah, but I guess like also like it seems to be more and more about the agentic platform as opposed to the model that you have access to. And so these platforms, there really isn't a clear winner amongst. First of all, there's hardly any agentic platforms. I mean, Codex is very new. Um, there's cursor agents. There's not that many out there, and they're kind
No,
of
there's about
they're,
half a dozen I've looked at, and
they're
they all do
okay. They're okay,
basically
but
do the same thing.
they're not like free form. Like you can't like use them to program another agent that the agents
Yeah, yeah,
can
yeah, yeah,
call. Like
exactly.
they don't have that self looping ability. So I really think there's some big wins to be had based on like whatever avenue we choose to go down first. Having being the first in the playing arena with a good agentic platform is going to be the deciding factor. Like if we turned up into any particular business and we're like, well, we have become skilled at using the agentic platform that we made, and it's niche, sure, kill us, but um, that's what makes the difference between teams doing something now is which agentic platform are they using? Because if you've got a good one, you can outpace the people who, I mean, if you don't have one, you're not even in the game. If you do have one and it's not yours, you can't change it to
Mm.
be to solve your unique problem. Because I'm sure that as soon as we hit something in anger with this, we're going to be finding that there's bumps and issues and things that need fixing, that you really need to reach into the internals of it and stir around at it.
Yeah, and from what I've seen with the agentic platforms I've used so far, they really do have quite a large overhead of getting up to speed on it, and
Yeah,
it is hardwiring. You're hardwiring these things.
it's too high. Like the harness with which you get to interact with it is it's controlled. Like it's first of all, it's a lot of it's closed. Like you can't see how the hell
Yeah,
it works, and it's purposefully designed to not be not self improving, but like self modifying.
yeah,
Because that sounds dangerous on the face of it, but self modifying is that's the utility from what that's what we need.
yeah, yeah, and that's how you accelerate past all these things that are
Yeah.
being. They're the agentic platforms at the moment are effectively still being hand built.
Well, I mean, this ours not, but yeah, absolutely. In terms of time, I guess that look, probably in the next day or two, I'll have for you a version that will probably feel about as the same as what the finished version is going to be anyway. It'll just
Mm.
be lacking resilience and maybe a little bit of speed at first, and it will be
No, that's
expensive to run, but who cares?
yeah,
Um, you'll be able to play with it to understand what it should be. And I would say, like, I'm tempted to say I want to get some feedback before we build it, but using the tool to build the tool, it's sort of like I really don't care. It's so quick and easy to make modifications that
mm.
I really don't. You can give me feedback, fine, I'll just change it. It's
Yeah.
actually, like it's actually not a problem.
I think well, I'm really looking forward to that. I think that will involve a number of very deep dive sessions over hours.
Yeah, I might. It's probably time to hop on a plane and come see you or meet you somewhere at that point.
So, something like that, or synchronize our clocks. I can do night shifts.
No, that
That's what
doesn't
I'm
work
hoping.
out well. We can try, but I don't think that works out well. But yeah, we'll see. Anyway, I'll get this thing up a couple of
Yeah,
days, and then we'll see what parts need strengthening or optimizing if the bills get like wild. But then yeah, that's
yeah, nice.
pretty much it, buddy.
Okay, man. Yeah, do that.
Okay, I will. I will do that. Yeah. All right. I'll
All right.
knock off there.